Alright, so in this example problem we have a metal bar of 15 meters, so we have our metal bar that's 15.15 meters long. And it's hooked in series with the conducting metal U that we have represented here. And this U has a resistance of 15 ohms. The metal bar is on wheels so that we can pull it, so we're going to pull it to the right with a velocity of 1.5 meters per second. And we have this uniform magnetic field of 0.9 teslas going into the page. So the first thing we're going to want to know is the magnitude of the induced current. So in order to find the current, we need to find the induced EMF. So we're using our new form of Faraday's law, where we're given the velocity of the bar, we're given the magnetic field strength, and we're given the length of the bar. So we can find the induced EMF. We can then use Ohm's law in order to find the current using the resistance that was given in the problem. So that gives us our induced current. Now we need to establish what the direction of the induced current is. Alright, so because area is increasing, that means magnetic flux is increasing. That means the magnetic field needs to be in the opposite direction of the external field or out of the page. So if I point my fingers, grab the metal bar, and put my fingers through the loop that the U makes, my thumb is pointing up, which would mean that the current is flowing counterclockwise.